Okay, so a scatter plot. Scatter plot is a visual comparison of two variables in the data set. Helps identify the type of function that it describes the relationship between two variables. So not always will data fall on a perfect line, but data may follow a pattern of a certain function. So if you saw this data, even though it's not a line, what would you say, what shape does that look most like? Huh? A quadratic, right? If you kind of sketch a line in there. What was that? Okay, so it's quadratic. Okay, the second one. What does that generally look like?
That looks like linear.
Yeah, you can kind of find a line somewhere in there, right?
But it's a weak linear.
That's not that weak. We'll get to that in a little bit. Okay. What about this one? What do you kind of see here going on? Exponential. Very good. We can abbreviate that if you want. EXP. Yeah. Yeah, you can kind of find a V in there, right? You can abbreviate that also. So absolute value. These will be very quick notes. Okay, now correlation. Scatter plots can show a relationship between two variables. The relationship is called a correlation. Okay, you really hung up on that. It can be positive or negative. You just do the symbols instead of writing the words. If you want to write the words, go ahead. But positive or negative. Plus. Now, if you think about what this looks like, what do we say this one will look like? Well, yeah, it looks kind of linear, right? So if we looked at the line that's inside the cloud of data, right? If we look at the line, is it increasing or decreasing?
Decreasing.
Okay, so as it says, what happens to y as x increases? So as x increases, y increases. Okay, it goes up. So in other words, as we go right, it goes up. Okay? Now, if we look at the next one, kind of find our line somewhere in the middle of that cloud. As we go, as x increases, what happens to y? It goes down. So as x increases, this is x, that's y. As x increases, y decreases. Now, what function does that cloud represent?
That's no zero correlation.
Yeah, there's no correlation. Zero correlation. Very good. No correlation. That's just a mess. That's just a blob of data. Okay? There's nothing there. Okay? Now, someone mentioned this. It's not in the notes. But if you look at the line and you look at the data, this is important. If you look at the line and you look at the data, the closer the data is to the line, the stronger the correlation is. Okay, so I use an example. Has anybody ever seen a fly strip?
Yeah.
Okay, you hang a fly strip and it's got like yellow sticky stuff on the flies that are attracted to it. There's a smell, right? At first, when you put one up, the flies are just like all over it, crazy, right? But over time, then you'll see some flies kind of around here, and then maybe around here. It's not as, because the odor is losing its odor, so it's not as strong, so the flies are not exactly as tight around the line, okay? So for example, you put the fly strip, and at first, they're all like this. Like, oh, let me get to that stuff. It's yummy. Okay? That's a strong correlation. But as you have more over time, you know, it's still there, but what's happening to the odor is getting weaker, right? So there's still a correlation there, but it's getting weaker. So the tighter everything is in line, the stronger it is. The more away from the line, the weaker it is. All right?